Thorne's breathing apparatus made a soft hissing sound. The shuttle descended through the outer atmosphere of Graven 4. The readings on the atmospheric scanner were wrong. They had to be wrong. Thorne adjusted the scanner's calibration for the third time. "Pilot, I'm getting impossible readings from the surface. The atmospheric composition should be lethal to carbon-based life forms." The human pilot was a cheerful woman named Kate. She glanced back from the cockpit. "Oh, that's normal for Graven 4. Lane's been working down there for 2 weeks now. She says the air's a bit dry, but otherwise fine." Thorne's 4 eyes blinked in sequence. The atmospheric analysis shows sulfuric acid concentrations at 67%. The remaining gases include chlorine, hydrogen sulfide, and trace amounts of fluorine compounds. "Yeah, Lane mentioned that," Kate said, beginning the final descent. "She's been complaining about the smell." The shuttle touched down on a rocky outcrop that jutted above the planet's perpetual cloud cover. Through the viewport, Thorne could see the surface disappearing into a roiling mass of yellow-green vapor. The clouds moved like living things, pulsing and shifting in patterns that suggested violent chemical reactions. Thorne asked, "Your environmental specialist is working in that," Kate replied. "She's probably taking readings right now. Want me to radio her?" Before Thorne could respond, the shuttle's external sensors detected movement in the toxic fog. A figure emerged from the clouds. The figure walked with casual confidence toward the landing pad. The human woman wore standard work clothes, a utility vest, and what appeared to be a simple breathing mask. Kate observed, "That's Lane, right on time." Thorne watched in fascination as the human approached. Her movements were unhurried, professional. She carried a tablet in one hand and a collection device in the other. As she walked, she occasionally stopped to take readings. Then she continued toward the shuttle. "The atmospheric conditions should dissolve exposed skin in minutes," Thorne whispered. "Lane's pretty tough," Kate said. The human woman reached the shuttle and knocked on the hull. Kate opened the airlock, and Lane stepped inside, pulling off her breathing mask. She had short auburn hair and looked remarkably normal for someone who had just spent hours in an atmosphere that could kill most galactic species. "Morning, Kate," Lane said. "And you must be Thorne. I'm Lane, the environmental specialist." Thorne's translator struggled with the casual tone. "You were working in those conditions without a full containment suit." Lane glanced out the viewport at the toxic clouds. "It's not that bad once you get used to it. The sulfuric acid content is actually lower than the initial reports suggested, more like 63%. "That's still lethal," Thorne said. "Not if you're careful," Lane replied. "The real problem is the humidity. Makes everything feel sticky." She handed her tablet to Thorne. The environmental readings were comprehensive and detailed. Temperature fluctuations, wind patterns, chemical composition analysis, and atmospheric pressure measurements, all taken from direct observation in conditions that should have been impossible to survive. Thorne asked, "How long have you been working on the surface?" Lane replied, "About 6 hours today. I started before dawn to get the best readings. The atmospheric activity is more stable in the early morning." Thorne's breathing apparatus made a sharp wheeze. 6 hours. "In that," Lane said, "I took a lunch break, came back to the shuttle around midday. Kate made sandwiches." Thorne observed, "The chemical composition would corrode most materials. Your equipment should have failed within minutes." Lane examined her tablet. "I coat everything with a polymer sealant. It's the same stuff we use on Earth for outdoor equipment. Works great in acid rain." "Acid rain, Earth weather," Lane explained. "You learn to work around it." Kate started the shuttle's engines. "Where to next, Lane?" Lane replied. "Survey Zone 7. There's a thermal vent system I want to check out. The readings suggest some interesting chemical interactions." Thorne consulted the planetary survey data. Survey Zone 7 was located near the equator, where the atmospheric density was highest. The temperature readings indicated surface conditions approaching 200 degrees Celsius. The thermal activity in that region is classified as extreme hazard, Thorne said. Perfect for thermal vent analysis, Lane replied. That's where the best data comes from. The shuttle lifted off and flew deeper into the toxic atmosphere. Through the viewport, Thorne could see the surface of Graven 4 for the first time. The landscape was a nightmare of chemical erosion and geological violence. Massive fissures split the ground, releasing jets of superheated gas. The rocks themselves seemed to be dissolving, creating streams of liquid metal that flowed like rivers. The geological activity is extraordinary, Thorne observed. It's definitely active, Lane agreed. Makes for some great geological samples. The shuttle touched down near a cluster of thermal vents. Steam rose from the ground in thick columns, and the air shimmered with heat distortion. Thorne's sensors registered surface temperatures of 197 degrees Celsius. I'll need about 2 hours to get a complete thermal analysis, Lane said, checking her equipment. 2 hours, Thorne's voice pitched higher. The surface temperature will cook most biological tissue. I've got cooling gel, Lane said, showing Thorne a small tube. Military grade, keeps you comfortable in desert conditions. She opened the airlock and stepped out into the superheated atmosphere. Through the viewport, Thorne watched her walk toward the thermal vents with the same casual confidence she had shown earlier. She moved between the jets of steam, taking readings and collecting samples. This is impossible, Thorne whispered. Kate looked back from the pilot's seat. Lane's from Arizona. She says this reminds her of summer back home. Arizona, desert region on Earth, Kate explained, gets pretty hot. Thorne activated the shuttle's external cameras to track Lane's progress. She was kneeling next to a thermal vent, holding a collection device directly in the stream of superheated gas. The readings indicated temperatures above the boiling point of water. She's collecting samples from a thermal vent with her bare hands, Thorne said. She's wearing gloves, Kate pointed out. Work gloves, not thermal protection gloves. Work gloves. Lane moved to another vent, then another. She worked methodically, taking measurements and recording observations. After an hour, she returned to the shuttle carrying a full sample case. How did it go? Kate asked. Great data, Lane said. The thermal output is consistent with the preliminary surveys. The chemical composition is fascinating. We're looking at some really unique mineral formation processes. She handed the sample case to Thorne. Careful, some of these are still pretty warm. Thorne accepted the case with trembling hands. The samples were clearly labeled and organized. Each one represented direct collection from conditions that should have been fatal. The thermal vents are producing some interesting chemical reactions, Lane continued. The sulfur compounds are interacting with the metallic deposits in ways I haven't seen before. I'd like to get more samples tomorrow. Tomorrow? Thorne asked. Different time of day, different atmospheric conditions, Lane explained. Morning thermal activity is usually lower. I want to compare the chemical output. The shuttle lifted off and headed toward the orbital station. During the flight, Thorne reviewed Lane's data. The environmental analysis was thorough and professional. Every reading was documented. Every observation was recorded. It was the kind of work that would normally require a full research team and months of remote sensing. How long have you been doing environmental assessment? Thorne asked. About 15 years, Lane said. Started on Earth, moved to off-world assignments about 5 years ago. What kind of environments have you worked in? All kinds, Lane said. Polar regions, deserts, volcanic areas, deep ocean surveys. Toxic atmospheric conditions, extreme temperature variations, high radiation environments. And you find this work enjoyable. It's challenging, Lane said. Every planet is different. You have to adapt your techniques to local conditions. The shuttle docked with the station. As they prepared to transfer to the main facility, Thorne's breathing apparatus began making irregular sounds. The indicator lights showed system warnings. Lane asked, "Is everything okay?" Thorne replied, "Equipment malfunction. The atmospheric exposure may have caused contamination." Lane examined Thorne's breathing apparatus. The intake filters are clogged, probably from the sulfur compounds in the atmosphere. Thorne said, "I have backup filters in my equipment case." Lane asked, "Where's your case?" "Still on the shuttle, in the cargo compartment." The shuttle had already begun its departure sequence. Kate was preparing to return to the surface for additional supply runs. The cargo compartment was sealed and pressurized. "The next shuttle doesn't arrive for 6 hours, Thorne said. The breathing apparatus made a sharp whistling sound. "No problem," Lane said. She opened her own equipment case and pulled out a small device. "I've got a portable oxygen generator. Military surplus. Runs on chemical reaction." She handed the device to Thorne. "Just plug it into your breathing system. It'll give you about 8 hours of clean air. You carry backup life support equipment." "Standard field gear," Lane said. "You never know when you might need it." Thorne connected the device to his breathing apparatus. The system warnings disappeared and the irregular sounds stopped. "This is military equipment. Bought it at a surplus store," Lane said. "They had a sale on emergency gear." "You purchase military life support equipment at sales. It's reliable," Lane said. "Earth military gear is built to last." They transferred to the station. The facility was a standard Class 4 science platform, designed for long-term environmental monitoring. Lane's quarters were small but comfortable, filled with equipment and data storage devices. Thorne asked, "This is your temporary living space?" Lane replied, "Home away from home. I've got everything I need. Shower, kitchen, communication equipment. The view's not bad either." Through the viewport, Graven 4 dominated the sky. The planet's toxic atmosphere created beautiful patterns of color and light. The chemical reactions in the upper atmosphere produced displays that shifted and changed like living art. "Do you find the planet beautiful?" Thorne asked. "It's stunning," Lane said. "Every day is different. The atmospheric patterns change constantly. Yesterday, I watched a storm system that lasted 12 hours. The chemical interactions created colors I've never seen before, but the surface conditions are lethal." "They're extreme," Lane said, "but that's what makes the data so valuable. We're learning about chemical processes that don't exist anywhere else in the galaxy." She activated her data terminal and began reviewing the day's readings. "The thermal vent analysis is going to revolutionize our understanding of mineral formation under extreme conditions." "You speak as if extreme conditions are desirable." "They're informative," Lane said. "Extreme conditions reveal processes that are hidden under normal circumstances. You can't understand the limits of chemistry and geology without studying extreme environments." Thorne's breathing apparatus made a satisfied hum. The backup oxygen generator was working perfectly. "Your equipment solutions are remarkably effective. Earth gear is practical," Lane said. "We design things to work under difficult conditions." "Earth conditions are difficult." "Earth is complicated," Lane said. "Variable weather, extreme temperature ranges, high radiation exposure, toxic atmospheric conditions in industrial areas. You learn to be prepared for anything." She pulled up a display showing Earth's environmental data. Earth has deserts where the surface temperature reaches 70 degrees Celsius. Polar regions where the temperature drops to -40. Volcanic areas with toxic gas emissions. Ocean trenches with crushing pressure and no light. And humans live in all these environments. "We work in them," Lane said. "Humans are adaptable. We modify our equipment and techniques to match local conditions." Thorne studied the Earth environmental data. "Your species evolved under extraordinary conditions." "We adapted to extraordinary conditions," Lane corrected. That's what humans do. We adapt. The next morning, Lane prepared for another surface expedition. She checked her equipment, reviewed her data collection schedule, and prepared sample containers. Thorne watched her routine with growing fascination. "You're returning to the surface," Lane replied. "Survey Zone 12 today. There's a chemical precipitation system I want to analyze. The atmospheric conditions create some unique mineral formations." Thorne observed, "The chemical precipitation involves acid rain." Lane agreed. "Concentrated sulfuric acid. Should be interesting." She put on her breathing mask and utility vest. "Want to come along? I can get you a spare breathing system." Thorne's 4 eyes blinked rapidly. "You're inviting me to accompany you to the surface." "Sure," Lane said. "It's always good to have someone to discuss the data with. You might see things I miss." "But the surface conditions—" "I'll keep you safe," Lane said. "I've got extra equipment." An hour later, Thorne found himself standing on the surface of Graven 4. He wore a breathing apparatus that Lane had modified with spare parts from her equipment case. The toxic atmosphere swirled around them, but the breathing system worked perfectly. "The key is understanding the local conditions," Lane explained as they walked toward the precipitation site. "Every planet has its own patterns. You have to learn to read the signs." She pointed to a formation of crystalline structures that grew from the ground like frozen trees. "The acid rain creates these formations when it reacts with the metallic deposits in the soil. The chemical process is fascinating." Thorne examined the formations through his protective visor. "They're beautiful. They're also constantly changing," Lane said. "The chemical reactions continue even after the structures form. They grow, dissolve, and reform in cycles." She began taking measurements, working with the same casual efficiency Thorne had observed before. The readings were precise and detailed. Every observation was documented. "How do you maintain such accuracy under these conditions?" Thorne asked. "Practice," Lane said, "and good equipment. Earth's scientific instruments are built to work in difficult environments." They spent 3 hours collecting data and samples. When they returned to the shuttle, Thorne realized he had just completed his first surface expedition to one of the most hostile environments in the galaxy. "That was extraordinary," he said. "It was a good day," Lane agreed. "Clear atmospheric conditions, stable thermal activity, perfect for data collection." As the shuttle lifted off, Thorne reviewed the data they had collected. The analysis was comprehensive and groundbreaking. They had documented chemical and geological processes that had never been observed before. "Your work is revolutionizing our understanding of extreme environmental chemistry," Thorne said. "It's just environmental assessment," Lane replied. "Every planet is different, but the basic principles are the same. You observe, you measure, you adapt to local conditions." "And you find this work routine," Lane smiled. "Every day is different. That's what makes it interesting." Thorne's breathing apparatus made a contented hum. The backup oxygen generator was still working perfectly. Earth military surplus equipment, purchased at a sale, keeping him alive in conditions that should have been impossible to survive. "Humans," he would later write in his report, "do not simply survive extreme environments. They treat extreme environments as workplace challenges to be managed with appropriate equipment and professional competence." The shuttle docked with the orbital station. Lane gathered her equipment and prepared to analyze the day's data. For her, it had been another successful day of environmental assessment. For Thorne, it had been a revelation about the extraordinary nature of human adaptability. "Same time tomorrow?" Lane asked. "Tomorrow, Grid 15, Lane said. "There's a gas emission system that's been producing some interesting chemical reactions. Should be fun." Thorne's 4 eyes blinked in sequence. "Fun? It's always fun to discover something new," Lane said. As she walked toward her quarters, Thorne realized that what humans called fun would be classified as impossible survival scenarios by most galactic species. But for Lane, tomorrow's expedition to a toxic gas emission system was just another day at the office.